All right, so welcome. This is coming up near the end of the afternoon session on day one of UGM2021. This is my office mate here at Rensi, but I haven't seen him in person in about 18, 20 months. So this is Raja, one of the original authors of IRODS and SRB, and he's here to talk about IRODS and observability. Take it away, Raja.
Hey, thank you very much. As is the, what do you call it? I don't know, ritual in a sense, I normally wear my oldest IRODS t-shirt for this particular one. So I'm doing that. I suspect you might be able to see it now, but if you see the t-shirt, you won't see me. So I'll probably get back to. Are you able to see my t-shirt by any chance?
Yes, that's a it's 2010.
Okay.
Very
now
good.
I'll go back to this one. So today I'm going to talk about IRODS and observability. Observability has been a new phenomenon which has come out where people have realized that they can't just be monitoring software, and that too in a cyber infrastructure which is pretty large and can span around the globe. So you need something more than that. And they started looking at how that can be done. So I'm going to talk about what is observability, and then what is IRODS doing currently which can help with observability, and then also look at how we can realize better observability through the IRODS system, and finally open myself to question and answers. So what is observability? Actually, if you know what is observability, please try to give a thumbs up in our general Slack channel. Maybe somebody will put up a simple query on that, and then you can answer that by doing that. I would like to know how many of you really know that. Basically, observability is the ability to understand what is happening in a system. And actually, it came from engineering. Basically, mechanical and other engineering people would like to know what is happening inside the system by looking at it, by observing it, by smelling it. Obviously, they were doing all sorts of things to see, okay, is the jet engine having a loose blade in there or not, and things like that. This was before they were trying to do instrumentation type of thing. And actually, instrumentation nowadays actually helps you to do a better job of observability than before. So it basically originated from control theory and how I can control the system so that it is working at the peak performance, so that I can take it from there. So that's what basically for dynamic systems. So you can see that it applies very well to software systems also. Basically with a highly distributed system, you would like to answer a specific question. How am I doing right now? Is there any particular part of it not working properly? So a lot of people are obviously interested in it. The administrators are interested so that the users don't get a bad experience. The developers are really want to know why it is happening, what is happening, and how they can improve. And obviously, the people who write the applications would like to know also, are they at optimal performance? Remember, during the olden days, it's very easy because they were all running on a simple system. It is very easy. Now you are touching upon a whole bunch of things, like what we saw in the Globus demo, that it was spanning multiple places to do something. So basically, observability enables you to realize what is slow, what is broken, and what are all the bottlenecks, and what is degrading the performance, and more importantly, what can you do to improve usage patterns, and how can you predict failure? So it's not just looking back at what is happening, what happened and what is happening, but also looking into the future and trying to figure out how we can be better in there. So increase resiliency, increase availability, and improve user satisfaction. And in particular for cyber infrastructure, this is really a big problem. So you can see, I put up a list of things which normally are happening whenever you have a large system like IRODS or anything else. Netflix actually started this particular ball game recently about this observability, because they were realizing that their whole network of systems is spanning the whole globe, and if anything happens anywhere which can create problems for them, it is going to reflect on the user experience. And they did a great job in trying to use observability as a means of doing a good job of doing improving performance and things like that. So agile programming actually is a good way of doing things, but they can also introduce things which you may not be able to control. Similarly, automatic updates, bug fixes, and stuff like that can actually go and change things and then create some problems in there. And then nowadays we use cloud services, multilingual scripts, complex security structures like what we saw in the Globus demo, and virtual machines running on different types of heterogeneous software and things like that. So it's basically a smorgasbord of things which are happening, and you don't know where things are going to go wrong. And like I said, it's not your old grandpa's slide rule any longer. It's more than that. So a very simple click to do something, maybe do a IRODS move data from your laptop into the IRODS cloud. You can span 2 or 3 hardware systems, maybe several, different kinds of authentication kicking in, and the storage systems and databases, and you can see that, and multiple pathways to get to that particular one in parallel, and so on and so forth. So you can see something which can happen in milliseconds can touch upon thousands and thousands of lines of code, and even if one of them is not working properly, you can get into it. So an innocuous update happening to an obscure package can have a cascading effect, and you don't even know where it is happening and how it is happening. And that is where the nightmare comes in, and you would like to figure it out. You would like to be on the ball and then try to prevent bad experiences, so that you can predict the failure and predict degradation of performance, so that you can throttle it in such a way that you are above the hoop before you can do anything. So basically, the answer to all these type of things, all these problems that are being created, is observability. So it is a practice for achieving actionable insights. So it is not like just by monitoring and things like that, but actually looking forward and then say, what can I do to help? So aim is to understand when an event or an issue has happened, and why it happened, where it happened, who or what is responsible. Who in this particular sense is basically some software package you might have added to something, and things like that, and how to recover from that particular event. Obviously, I'm looking at not a good event, but a bad event in this particular case. And more importantly, we would like to know before it happened, so that if it can say that something is going to happen in the future, I would like to stop. Again, and getting back to the jet engine type of thing, your observability is basically trying to figure out, is there anything wrong with the engine before the engine explodes or anything happens in the air? You would like to predict and diagnose it even long before you are able to get to that particular one. So that is where you're using observability as a way of dealing with that type. And it's a really good thing to do in a complex software systems like IRODS. And one more thing is that when we saw in our keynote talk about from Sanger, it basically is that IROD is one of the cogs in the wheel, and there are other cogs in the wheel also. So can these things have to work together, mesh together, and anything and anywhere happening can create trouble, and you would like to make sure that you're not getting into it. And obviously, with the advent of importance of machine learning and data analytics and things like that, slowly can we use those type of things in the IROD system to make it better and perform better. So if you look at some of the observability systems which are currently available, there are a whole bunch of them. Actually, if you go and Google and then look at the tools for observability, you'll see a whole lot of them. But there are, I just picked up a few. Grafana is Grafana. It's not Grafana. Is a really good one, which is also one of the things which is gaining strength. Data Stacks is another really good one. Apache Skywalker and OpenTelemetry are all open source software which are available for doing observability, and they try to provide you with a way of how to get the data in there and how to do monitoring, and then going beyond that and then trying to do things. So you can see where observability comes into the picture. So what is observability and how it can be useful? So here is something you can see, is that there are 3 pillars for doing observability: logging, tracing, and metrics. Logging is basically you would like to collect all the information that is possible you can get from the system. Obviously, do I collect or not to collect is to collect or not to collect is obviously always a problem, because anything you change in the system is going to create a problem. Okay, it is basically like high energy physics and a high end physics. Okay. And tracing is the second one, is trying to use the information that you collected, the data that you collected, and trying to get some value out of that one by saying, okay, what is happening in a particular transaction? What are all the different dependencies which are in there? So logging doesn't give you the dependencies, but taking the logs and then doing the trace analysis actually provides you with that type of dependency. And finally, at the third level is the metrics, which can be used for trying to leverage to build alerts to figure out what is going wrong and what is going right, and so on and so forth. And there are actually two more pillars. They talk about it, but they don't call them as pillars, even though I would like to call them as pillars. One of them is visualization, and other one is analytics. Visualization is where I can look at the dashboard of all the data I'm collecting in a system, and can I figure out using visual analytics or human analytics and try to figure out all the abnormalities, and if anything happening which is out of band or something which is an outlier, and you would like to pinpoint that and then trying to say why is that happening, and you can able to do that. Maybe there are 20 people connecting to IRODS, and one of them is not getting a good service. Everybody is exactly the same, and what is happening to this one particular person who is not getting it, and you would like to figure that out so that next time something like that cannot happen. Analytics is basically applying the logging information, the tracing information, the metrics information, and trying to predict false failures and service degradation by adapting and learning and from prior experiences. Tracing create an end-to-end view. In a sense, one of the things which can be said about this observability is trying to figure out what is the journey which a user is having when using a system. And they really call it journey, by the way. So tracing provides you with some bits and pieces of it, but you can pull things together and you can call that as a journey of what a user is experiencing. In a normal session, it may not be just one call going to IRODS and coming back, but it might be a sequence of them which are coming in. So you can say a journey consists of multiple sub-journeys, and inside even one journey, there can be some parallel paths happening, and some of them are basically touching upon different types of microservices and applying different rules and different functions, and so on and so forth, and obviously different heterogeneous systems, including storage and compute and so on and so forth. So you're basically looking at the sum total of all the activities and looking at a journey and trying to say, what is the person trying to do so that I can help the journey for the person. Okay, so in a distributed system, you can have multiple paths and you would like to stop that and then trying to see how you can do that. It can capture timings, it can capture all the calls which are happening, what are the return expressions, status code, and actually that is one of the metadata you would like to capture also. And the normal monitoring may not be capturing that, but when you are actually doing observability, you might be able to say, hey, I need to capture more than the normal thing and how I can do that. And the journey can be abstracted into templates. So you might say, hey, multiple people are doing the same type of journeys. Maybe that is a template. So I can find some sort of standardization, some normalization, and I can say, hey, this is what people are doing all the time. Maybe I can do something to improve those things, remove bottlenecks, and optimize it in such a way that it can work very well for a large number of people. So basically, one of the things you would like to do is not only find out about journeys, but you can also find sub-journeys, which are basically templates, and say, hey, this is something which is used by all the people. For example, if you're connecting to IRODS, you might say that some of the things which people do in the very beginning are very similar. And you would like to say, how can I optimize it? How can I speed it up? And so on. So how can IRODS help? What is the status of IRODS with respect to observability? Okay, currently, if you look at IRODS, we got multiple things going really good for it. Server logs. So you collect a lot of information about system events, error messages, and normal messages which are happening, and it can be used to find out about unexpected behavior. One of the problems with the server logs is it's highly distributed. So it is there in every server. It is not in one single space. The good things about the second one is the audit trail. We are collecting audit trail. Obviously, you need to turn it on with your rules and so on and so forth. But if your policy allows you to do the audit trails, you can get a rich amount of information of that one, which can be used to do the observability very, very nicely. And one of the good things about these audit trails is that centralized, because it is being collected in the at the metadata catalog level. So it's a good way of looking at that particular one. So even if you don't look at the server logs, the audit trails can actually provide you with a good sense of journeys which are happening inside that. And the third one is the metadata, status metadata. Currently, we collect some of the status metadata, but as you are trying to do observability in IRODS, you may want to collect a lot more richer metadata, which are basically about performance type of thing, rather than about the user-defined metadata or system-defined metadata. Something about performance-oriented metadata need to be collected. One of the good things is that it again can be in a centralized place, so that it can be persistent information, so that you can actually do a lot of learning out of that particular one. And IRODS is currently is more towards monitoring rather than about observability. And you can see the difference between what we mean by monitoring and what we mean by observability, in the sense that monitoring is basically an alerting system. Some error has happened. Maybe somebody can look at that particular error and say, hey, what is happening, and things like that. But most of the time, the error, when we collect the logs, we may not even, the system administrator or IRODS administrator may not even look at that, unless somebody sends an email saying that I'm having a problem. Then you go and look in the log to figure out what happened and why it happened, and so on and so forth. But we want to be proactive, not reactive. That means that the log itself is being taken by this observability system, which is basically a system which is standing outside IRODS and monitoring and analyzing it, and then trying to figure out if there is something bad happening and or something bad going to happen in anticipation. Okay, so what can we do with respect to observability? Right now, we don't have observability at all in IROD. We do monitoring, but not at the observability, as we can see. You can do two types of observability in IRODS. One is make IRODS perform better, be proactive in maintaining the performance in there. And obviously, the second one is an important one, which I have grayed out a little bit, is basically about how IRODS can help other systems which are interacting with the IRODS. If you richly instrument IRODS in such a way that you're doing very good observability, it can actually be used to figure out what is happening in the other systems which are connecting to it. And people can use to figure out if something wrong is happening or going to happen in the other systems, which might be a little bit of a black box. And you may not be able to perform observability in the system, but by looking at what is happening, how it is interacting with the IROD system, you may be able to figure out how it is doing. It is like you go to the doctor and the doctor asks you to do some things. And then by looking at what you're doing, they are able to come up with, okay, you're basically getting old or something like that. You can see my last doctor's visit, okay? So server logs, audit trails, status metadata in IRODS provide a strong and a very stable foundation for performing observability. But we can use policies and rules and microservices to make it better and do more things, and the metadata, and catch more metadata than what we are currently doing it, so that we may be able to perform observability. But what is currently missing are the pillars. Some of the pillars, we got a couple of pillars. The logs and tracing can be done. Tracing is not being done, but we can do that. Metrics is the one which is missing. Journeys are missing. Visualization is missing, and obviously analytics are missing. So I'm going to touch upon each of these in a very brief fashion, and just to give you an idea about what can we do in the IRODS to make it a better observed system. One of the main things which we normally look at whenever we talk about metrics is the APMs, Application Performance Monitoring, to check whether the system has really good performance. Does it meet the performance standard? If you have a service level contracts, agreements, is it meeting those service level agreements? Someone might say, I want to make sure that whenever somebody comes in and asks for a data file, they should be able to get the data file in 2 seconds or something like that. That might be the SLA contracts. And is it still meeting those type of things? Obviously, identifying bugs and potential issues and providing flawless user experience is also really a good part of that in there. And you would like to reduce the MTTR so that users won't get frustrated with the system, and proactively remediate without bringing down the system, trying to figure out what is happening, things like that. And we can do alerts and simple analysis as part of the metrics, which we can do. And here I gave not a comprehensive list, but some of the things which we can easily do in IRODS, which can be very helpful by collecting these data. Obviously, these are going to take a lot of space, and obviously they might have a little bit of performance degradation for all we know, because any measurement is going to spoil the system, is going to change the system a little bit. So you may get that, but you may get more out of it than what we are having here. So CPU memory, this one, database loading, request rate, responses. Response times is probably something really important because that is going to tell you if the user is going to get frustrated or not. What is the bandwidth everybody is getting? What is the throughput? Is there some really bad bandwidth or performance happening? It might be as simple as some DNS server not behaving properly, but it reflects in IRODS in a sense. How many threads are there? How many microservices functions are happening? And what is the time for each microservice call? And does it depend upon the attributes or the function or the values you're passing to it, and so on and so forth? How much uptime? How much time does it take to spin up? What are the restarts and how much of availability and so on? And obviously user experience. Right now, we don't even collect any user experience in a sense. Maybe there should be a I command for that, I like or something like that, where you can say I like, then you can say some happy face or bad face or something like that, which can get logged into there. And then overall, you might be able to say, hey, this person likes it or not. And other software KPIs can also be there, so that you can look at key performance indicators and then try to figure out, are we doing better or not? Journeys, like I said, is central because that is what users are experiencing. And you would, because of chaining of services and peer-to-peer connections, it is actually really hard to trace the activities in a session, because it is basically in many other things are happening in parallel, and they are happening across a wide area network. And getting that particular one and trying to figure out is really important to do that. And it can help you to identify bottlenecks. Maybe it is a network bottleneck, or it might be a storage bottleneck, or it might be a CPU bottleneck, but you can be able to see that there are problems which you can easily figure out and then try to do that. Session level performance journeys, you can easily see many other things, critical path analysis, root cause analysis, and so on are really important. What type of analytics can you do? Predictive, descriptive, and prescriptive analysis, like what I was talking before, but there is a whole bunch of other things which we can do in there. So here you can see the statistical analysis can be very useful for us. Analyze the metrics data so that you might be able to figure out whether are we meeting where we are with respect to what are the required insights. And it can provide a bunch of information about the latencies and what are the expected outcomes, and we can define that. And actually, that particular part is going to be used at a later stage when we use machine learning to figure out whether a particular journey is a good journey or a bad journey. People may not complain immediately, but when they get frustrated after a few times, they are going to complain, type of thing. So you would like to figure out what is happening in there. So that is where you may take a whole bunch of journeys and try to throw it at a machine learning system so that it will be able to figure out whether a journey, one journey coming in is a good journey or a bad journey. So you would like to find a bad journey before a user starts complaining to you, so that you should be able to get to that and then try to mitigate what is happening. Graph analysis is really important because a lot of the journeys are completely doing very complex graphs in there, and they are also going across in a topology, in a sense. Adil will be really happy to hear that, and you can see that, yeah, you are getting into a lot more in there. You would like to know about critical nodes, most used nodes use nodes in the journey, and which are the ones which are need to be improved. Pre-staging and actually, this is another one you can do. If you know particular journeys are really normally taken by somebody, you might do the second part of the journey before. So some prefetching type of thing can be done. So you can actually predict what the user is going to do, and you can basically do some things before they want it, so that you can actually increase and improve the user performance. Obviously, if you're using a lot of data coming in, and many of the data are based on error, what do you call, the log files and stuff like that, you can do text analytics in there. And finally, this is very important. Machine learning can be used to find patterns, and then successful journeys and failed journeys, and so on. And a whole bunch of other things can be done. There are a lot of different types of analytics which can be applied, and I just give you some simple examples of what we can do. In a sense, we just scratch the surface. It's a lot more complicated, can be done, and IRODS is rich in the logs and the traces which are being collected. So actually, you can do a lot more than different systems which are not being instrumented. IRODS is very well instrumented to do a whole bunch of these type of things where other people cannot do it because they haven't done that when they did the software development. But nowadays, that's what is happening. People are developing software with observability in mind, but not like the old legacy software. You don't have that luxury. Visualization obviously is a really important part of observability, and that's where a system administrator's dream is. They can look at it and then try to figure out what is happening and things like that. And I just gave a simple, this one, I think this is coming from one of the O'Reilly books, but it is basically, I think, Grafana or somebody one in there. So IRODS and observability is becoming really important. It's becoming really complex. IRODS is, you want high availability and high throughput is being demanded by the user community. So you would like to apply IRODS and observability together. If you want to monitor the system continuously and want not to just monitor it, but also try to figure out if anything is going wrong and correct them on the fly. And observability also is really important for IROD because developers can have can find out what is happening in the system. So they will get automatic feedback in how to do that because of the monitoring, continuous monitoring and continuous performance in there. You're actually able to get a lot more out of it, and the developers will be really happy to get that type of insight of what is happening. Not just somebody puts up a bug, this one report. They would like to know a lot more than that, and then this is going to be very helpful. Multiple assets, like I said, is already available, and we can use those things. But we need metrics, we need journeys, we need analytics, we need visualization. Good idea to think about when we already do enterprise level applications. We are already there, and why can't we do it? And like I think Pete mentioned today morning, reliable resilience, scalable resilience is really needed. And you want to get to that particular level, you need to get a very good amount of observability to do that. You cannot do it blind. And observability actually provides you with that open face to do that. Okay, I think I'm done and ready for questions.
Very good. Yeah, we've got a, thank you so much. We've got a discussion here in Slack about the audit plugin and how it's, can send a lot of data, can send all the PEPs in the system can be fired at the same time. We saw that, Grogan was actually turning off 95% of the things that it was sending.
Actually, that's right. Yeah, IRODS is rich in that particular sense, right, compared to a lot of other systems which are not developed with observability in mind. People are actually designed to observability is a really good topic now in software engineering. Now, how can I design towards better observability?
That's right.
I know one of the IRODS is one of the forerunners in doing that because of these type of audit trails and pre and post things and stuff like that. We are really good at that right now. But what we don't do now is the other things, analytics. We don't do journeys. We don't do metrics. We don't do constant continuous monitoring and things like that. And obviously we don't do any machine learning with what we learn to figure out.
Yeah, I think in terms of things that sit inside the small circle of IRODS would be definitely things around, like you said, the journeys. We've got in the master branch now, we've redone all the logging. And so the logging is much more rich. It tells you from where the client came, which server was connected, and it would allow you, it has all the information for a tool that has not been built yet to show the threads across the multi-hops in a distributed system.
I think this is what we need.
Yeah. The other stuff, I think it sounds mostly like a deployment thing or kind of a standardization of how people would expect this stuff to be packaged. But yeah, you're right. We have all the information.
Yeah, it is outside IRODS because you're collecting it, and then outside IRODS, you would like to do that, and probably the one we have like the Rabbit MQ and stuff like that will be very useful because you would like to get into one place. Right now, if you look at the logs are all distributed, but you want to collect them so that you can if you want to do the journeys, you would like to collect them.
Right. So in master now for 4.3, we've got it's all syslog based, and so if you point it to a remote syslog server, that's one of the things that you could do. And we've got a question from John Constable asking basically. So IRODS is unique in that it can do all these things, but other tools exist for other areas for like monitoring and logging. And he's asking if Raja has a feeling as to which would be the best place to start. Do we address IRODS strengths and avoid duplicating other projects, or do we start to partner with certain things that would be the biggest bang for the buck right now, kind of in terms of?
Yeah, there are, like I said, there are now a whole bunch of monitoring tools that are available, a whole bunch of things which do quote unquote observability as is. So you can plug those tools, like Grafana is one particular tool, which I just showed, and open telemetry is another tool.
I've seen that one as well.
Things like that. So you can plug those things. I would not completely rebuild anything like that. I would like to see how I can take those things, plug them in there, and many of them provide all the things, like I said, tracing, journeys, metrics, and a little bit of analytics type of thing. They already do that. So you may want to plug those type of things and try to leverage the amount of data which IRODS can have and try to do that.
Right. So yeah, Mike Conway's asking about, he's saying that, iDrop was built to schedule large transfers and be able to walk away and see the metrics and figure out how to do things like that. And he's wondering how the dynamic PEPs potentially play. And I think, you basically answered it already. In terms of monitoring agents, we don't do that ourselves. We're hoping that's maybe something that the asynchronous task manager thing that we were talking about earlier, kind of better monitoring internally and measuring some throughput and health checks and things like that could be shared out to these existing systems.
Yeah, in a sense, I think what Mike said was very good. The iDrop was doing it, but it was not collecting it and keeping it so that you can use that. That was the main problem.
That's right.
You're looking at it, and then after that it disappears. Right. So, and one of the things is that you would like to take sense. And I think if you ask Nirav, and I suspect it is the same with John Constable also, is that they probably collect some of the IRODS logs and audit trails, but after some time it fills it up, and you need to do something about it and things like that. But maybe that is where you have a learning engine or something like that. Then you throw it at the learning engine, it will learn something, and then after that you can throw away some of the whole thing. You may look at the mean, the median, and like it is like the rainfall. They collect the temperature and rainfall and things like that, but they don't keep it. They just say, okay, what is the high, what is the low, what is the minimum? Same thing with stock market. They monitor it every second of what is the stock price of a particular equity, but they don't keep it. They just say, okay, it started with this, we ended with this is the high, this is the low, and so on and so forth. So you basically try to aggregate and put things in there. And those are the aggregation we need to do with IRODS data. Collect a lot, aggregate so that you don't waste space.
That's right. Yeah, we've got a couple more comments about needing a Brendan Gregg for the flame graphs. Have you seen flame graphs before for measuring performance and where the slow parts of your system are? Or
yeah, there are, yeah,
trace or BPF style trace points. I think we can actually do a lot of that now. We just don't have the machinery to catch it and draw the pictures. So.
Exactly. That's what I think we need to do that, and it will be really useful for all of our customers, because they would like to get that's why the dashboard is there. Right. So if you can give that as a package, as an observability in IRODS as a package, and give it to them, they can just open it, and then it automatically starts, and give them the what do you call, where are all the servers are there, or it can go and pick it up from the MCAT ICAT catalog, and then boom, it automatically starts running, and then trying to tell, hey, this is wrong, this is something you got a DNS problem or something.
Right. It's always DNS. That's good, because
Ilya is going to come and kill me.
Very good. Thank you.
Thank you.
Always a pleasure.